Our next talk is by Alluxio from the Alluxio team on accelerating cloud training with Alluxio. All our old friends from the community probably already quite familiar with Lu. She is our machine learning engineer at Alluxio and also a PMC maintainer of the open source project. She develops a big data solution for AI and machine learning training at Alluxio. She's also the host for our AI and ML machine learning track community DevSync. She can tell you more about it. So if you are currently using or if you're planning on using or experimenting with Alluxio for your machine learning workload, she will be the person you want to talk to, either on Slack or join her DevSync. And grab her at the monthly sync along with other contributors. That's where we can discuss a lot of technical issues and deep dives, and also plan our roadmaps. So who are working together on this track. Since it's open source project, we do appreciate all your contributions and all your input. Today, Lu is going to introduce a 3-level progression to use Alluxio to speed up your cloud training with production use case from our community users such as Microsoft, Alibaba, and BossZhipin. Without further ado, let's hear from Lu's accelerating cloud training with Alluxio.
That's just me for all the introduction. Let me just share the screen and start it. So hi everyone. Exciting to see the Alluxio Day 15, and today I will talk about how to accelerate cloud training with Alluxio. Just as Jasmine mentioned, we will talk about 3 levels of how to use Alluxio in cloud training to actually speed up the whole process. So I will skip the introduction. I think Jasmine already did a great job. So for today's agenda, basically we will focus on 2 parts. We will really briefly introduce Alluxio and its POSIX API for any of the new Alluxio Day person that haven't been familiar with Alluxio and POSIX API. And also we will focus on the how to accelerate cloud training with Alluxio. 3 rounds of usage, how to accelerate the cloud storage read, and how to accelerate from data preprocessing to training the whole workload, and also how to use Alluxio as a data orchestration layer to speed up the whole process, the data ingestion and ingest the whole process. So first, we will really quickly go through what is Alluxio and its POSIX API. So Alluxio, as many of you guys already know, that Alluxio is the data orchestration layer for analytics and AI in the cloud. So basically, under Alluxio, we have different cloud storage and different distributed storage like HDFS and Ceph. And those cloud storage were connecting to Alluxio and form in Alluxio unified namespace. Basically, through the Alluxio unified namespace, you can access data in different kinds of storage systems. And on top of Alluxio, we also support different compute and training frameworks like Presto, Spark, and TensorFlow and PyTorch. And those compute frameworks or training frameworks, they can access the unified Alluxio namespace through different interfaces or different APIs. And aside from the accessibility, Alluxio can help us do the read, write, and buffering. So usually our data reside in some remote storage like object storage or HDFS. And all our compute job or training job, they need to go through the whole network to reach our data remote. And the whole network IO and all those things may really reduce our IO throughput and also increase our metadata latency. So by putting Alluxio closer to our training job and compute job, we basically can help how to give the local data performance for our training job, which is much quicker than fetching through the network. And on the other hand, we also helping to make the metadata to your local. So I think for many of training job, it's like tons of small files. And when tons of small files, the metadata can be a really huge overhead for our remote storage. If each time we need to go through the network to our remote storage, first, the latency may be high. Second, our object storage may be under really high pressure, and it may reduce your request rate or etc. just to fail a request. So by putting Alluxio closer to our compute, we provide the local metadata locality, and also Alluxio help you to synchronize between different clusters and synchronize the data between your on-prem cloud storage or HDFS cluster with your Alluxio cluster for your training job and compute jobs. So what is Alluxio POSIX API? For Alluxio, we have an Alluxio unified namespace that basically through that namespace, you can access data in different remote storage. And Alluxio POSIX API made one step further. It can mount the Alluxio unified namespace into your local folder. So you can access all the data set in your remote storage system, just as your local folders. So here we give a more concrete example of which we mount basically the Alluxio namespace into a local folder called Alluxio. And you may feel that it's a local folder, but it may represent like different remote and distributed data storage. And under that folder, there are probably some subfolders that you feel is local, but it actually represent like HDFS, or it may represent like object storage, etc. And those data may be already be cached by Alluxio, so you can access it at local rate, or it may still in your remote storage that you need to go through the network to fetch it. But for application, they just use it as local file and local directories. So after we talk about what is Alluxio POSIX API, basically it Alluxio POSIX API allows all the training and compute job to access all the remote data as local data. So that's it. So not going to details. And now we talk about how to we actually use Alluxio in our training pipeline, in how to accelerate the training pipeline basically with Alluxio. So the round one, basically we want to accelerate the under storage data access. So in this use case, basically our data is stored in our under storage. It could be in cloud object storage, or it could be in HDFS and SAP. And our training cluster need to use those data. Traditionally, we have two ways of doing that. We either copy the whole data set from object storage to each of the training machine, or we use some of the object storage fields, like some of the application, to fetch those data on demand and remotely every time we need those data. But by using Alluxio, we can set up Alluxio cluster that really close to our training cluster, and the data will be fetched from our object storage only once and be cached in Alluxio. So all the following requests will be go through Alluxio instead of the remote storage. So we can we can increase the throughput by a lot in this way, since the data is much closer to our training jobs. But this use case, it basically have two requirements. First is that the data basically is reside in your object storage, and it can directly be used for your training job. Or your training job, actually not just training, it also contains the data preprocessing logic. So that's the use case one. And to use this use case, it's pretty easy. You can use one click to mount your data set, your training data set to Alluxio, together with all the credentials that's needed for access the data set. And also you can use one click to load all the training data into Alluxio. After this two clicks, basically your training job can directly access the data in Alluxio in remote storage using Alluxio. So we take a detailed example. So in Microsoft, they have more than 400 tasks that need to read data from Azure and write data back. And the total data size is larger than 1 terabyte. Previously, they directly copy the data from cloud to each of the training nodes. But by using this way, it has several challenges that they are facing. The first thing is that they need to copy the whole data set to each of the training machine. The copy itself is really error prone, and the Azure or other cloud storage, they have the request rate limit. Basically, you cannot request data that is a certain rate in a certain period of time. And also the GPU needs to wait for your data to be ready to start your training jobs. The waiting phase is really like resource consumption. Like the GPU basically is idle, it's waste. And their way is to put Alluxio in between. Basically, they put an Alluxio cluster closer to their training jobs, and that Alluxio cluster go to your remote storage to fetch the data only once. And those data can be shared by all the training nodes and all the different tasks. And because they are using Alluxio, Alluxio can do data prefetch. And the training job does not need to wait for the data prefetch to finish. Basically, it can directly start. And if the data is cached in Alluxio, Alluxio provides the data, provides the local performance data. And if the data is not in Alluxio yet, we will go through a network to help our training job to fetch the data remotely. And also our data prefetch in the backend can help us to speed the future data access. So by using this way, we largely increase the GPU usage, especially at the beginning and end of the training jobs. And also this streaming data really dispatches the IO requests to our storage system and to make our storage system more stable and make our read requests more stable. So the first one is more about how we speed up the training itself. And the second one, we actually focusing on how can we speed up the data preprocessing and training workloads. Because as I mentioned before, our data may not be ready for our training, or our training job may not include the data preprocessing logic as well. The data preprocessing and training, they are maybe like fully separated, and there needs to be some way to connect them together. So I will just skip this slide, maybe use a really concrete example for that. So in BossZhipin, they use Spark and Flink to preprocess the data, and they want to do training on top of those preprocessed data. Basically, Spark Flink process data and training needs it. And their previous solution is to use Ceph in the middle. Ceph is the persistent storage. And the problem of this approach is that they basically, all the temporary files of Spark Flink, they also need to be returned to Ceph. But Ceph is a persistent storage, and it will cause Ceph to be under really high pressure, which is not needed. And also because they are using Ceph for all the ETL jobs and all the model trainings. You know, the ETL job and model training, they may be bursty according to the actual needs. It doesn't mean that it will be consistent load. So sometimes Ceph will be under really high pressure when you have more training job running. And all the training job as you guys know, is like really high concurrent. So it will put a lot of like metadata and data pressure to Ceph itself and make Ceph really unstable. And so they think that maybe they can put something in between. They want the preprocessed data to be persisted to Ceph, but they also want to like solve the problems that they are facing. So they put Alluxio in the middle of like compute and storage. So now in this time, the Spark Flink will write the data to Alluxio. Alluxio will asynchronously persist the data that actually needs to be persisted to Ceph in the backend. And before the persist finished, our training job can already get the processed data and use that for training. It does not need to wait for the persist stage to finish. And they can do that because Alluxio supports multiple different data sources and multiple compute and training frameworks. And if they have more ETL jobs and especially more training jobs, they can basically launch more Alluxio cluster to face those burst needs, and those will be isolated. So basically in their cases, they have big data ETL job like Spark and Flink to pre-process their data. And those data was written to Alluxio. And the training job like training framework like TensorFlow and PyTorch will read those processed data for training. And Alluxio in the backend, we will persist the data to Ceph and HDFS for future needs. So in this way, we can improve the under-storage stability. We are able to speed up the whole data preprocessing to training pipeline. And we can launch more Alluxio clusters to meet the burst ETL and training requirements. But sometimes people may not use like big data ETL tools, Spark Flink for data preprocessing. And there are other tools that they are in favor of. like C++ and Python scripts. So many of the preprocessing logic is written on those languages. So in this case, they may read the raw data from HDF or object storage through Alluxio, and they do some data preprocessing and return those preprocessed data back to Alluxio. And similar to before, the training can directly use those data for training, and Alluxio can help process the data in the backend. So basically, that's how we speed up from data preprocessing to training the whole pipeline. But as the round 3 of the games, we want to use Alluxio as a data orchestration layer, not just in some limited scenario, but also as a whole layer. So what do I mean by using it as a layer? So for training jobs, no matter where your data is and what data preprocessing is needed, it can be located in under storage systems. It can be need to be processed by ETL tools or some programming scripts. No matter where, Alluxio Alluxio can help catch those data closer to our training jobs and provide the read buffering for our training job during the read workloads, the data ingress workloads. And on the other hand, for all the data return, we can also go through Alluxio. So no matter it's like temporary file that generated by our ETL or our training jobs, we can temporarily return those files to Alluxio. And for those data that need to be persisted, either our preprocessed data from the ETL or data preprocessing scripts, or is the training results, the data that we want to persist, we can return it to different under storage by Alluxio. And the saying that all the jobs doesn't need to wait for Alluxio to finish persisting the jobs, and they can directly end their jobs. Basically, we are using Alluxio as a data orchestration layer between analytics, AI, and also our under storage in all the data read flow and write flows. So maybe another example. So in Momo, they actually using Alluxio basically as a data orchestration layer for their like searching and training tasks with multiple different storage systems. They have multiple Alluxio clusters, includes thousands of Alluxio nodes, and stores more than 100 terabytes of data. And it serves all their different kinds of tasks like searching, training, and all the other new use cases that they are continue to develop. And they are using it this way because Alluxio supports multiple under storage and multiple compute and training frameworks. And it can accelerate those compute and training tasks by preferring the read-write buffering. And we largely reduce the metadata and data overhead of the under storage system. So one of the use cases that they did is that they use Alluxio for building image training. They have 2 billion of small files. They use PyTorch to training, and they put Alluxio in between their PyTorch tasks and also their under storage like HDFS and SAT. And they largely reduce the metadata and data interaction with SAT to improve its performance and stability. And they also use Alluxio for some of the recommendation system model loading and some index loading as well. There are more use cases that they are sharing. So in summary, Alluxio may help you if you have the one or more of the following use cases. If you have distributed training, if your data set cannot be fit into a single machine, like you have terabytes of data, especially when you have large amount of small files or small images. And another approach is to basically get the data through the network. But if the network IO cannot satisfy your GPU requirement, basically your GPU is under like low usage or your GPU is idle, you probably will consider like using Alluxio to improve the overall utilization. And the other thing that is really helpful and is saw in many of the use cases like BossZhipin and Momo is that especially useful when you have multiple data sources and you have multiple training and compute frameworks. Alluxio can help like you bridge the data processing to training the whole full pipeline. And also, if your under storage like self is unstable and face like really huge pressure, and also your cloud storage system have like request rate limit, or it just costs you a bunch of money, then you may want to put Alluxio in between to help meet the burst need of your compute and chaining jobs. And Alluxio is especially helpful if you have data that need to share between multiple chaining tasks. So the same data set loading once cached in Alluxio and can serve like multiple different chaining tasks in thousands of nodes. And lastly, really thanks to our excellent engineers from different companies to drive this project and make it come true. And that project is already in production in different companies. So this project is not a high-level design from Alluxio, but basically one of our community users, they come to us to say, hey, we have the needs of accelerate our cloud storage with chaining. But can Alluxio use in this scenario, or can we actually make this solution happen? And they come to us, we figure out the solution together, and we iterate together, and eventually be in production together. So that's basically a community-driven project. So if you guys are interested in contributing to this project, feel free to reach out to us. So about how to deploy and actually use Alluxio POSIX API, especially in your chaining. For deployment, please click on our Alluxio IO, Alluxio Day link. Probably many of you guys register this talk through this website. And from our previous Alluxio Day 12 talk, one of my coworkers, Sean, gave a talk about how to deploy Alluxio on Kubernetes, especially for the chaining jobs. And on the other hand, we have the Alluxio POSIX API doc that talks details about how to actually mount Alluxio as a local directory and how to actually access those data. So all the details are inside this page. And if you have any other questions that you want to reach to our engineers, that feel free to on our Alluxio Slack channel. So we have all the engineers that we talk about the problems that the bugs that we figure out in Alluxio POSIX API or Alluxio, and also talk about how to generate the next level solution or how to make our solution better. So basically, there are people that answer your questions, and there are people that you can discuss your technical problems with. And all the other talks and blogs we are sharing in our website and social media. I think Jasmine already taught this part a lot. Now back to you, Jasmine. Oh, probably any questions?
Yeah, thank you. Thank you. Well, yeah, now you remember to ask questions. I almost forgot. Thank you for sharing. Sean's talk. It's actually quite relevant to what you're talking about. So I did have a question for you. Can you elaborate a little more on how a user would write to Alluxio cache, and if there's any flexibility on where to write?
Yeah. So basically, Alluxio supports different kinds of write type. So for a certain data set, you can set that, oh, I want to write to Alluxio cache only, then we only will write to Alluxio cache. You can see it as a temporary file storage. Basically, the data may be lost in the future if you shut down the Alluxio cluster. But you can also write to the under storage as well. So we have write type that only write to the under storage. Basically, Alluxio is only an access point that you can access the storage. So we persist those storage in our under storage. And the one thing that really useful in chaining workloads is that we can write to Alluxio first and provide to our chaining job. But on the backend, Alluxio itself will handle how to asynchronously write into your under storage to make sure that the data is persisted. But the data is also available for chaining job to use when the Alluxio cluster is on and when we have enough cache storage. Does that answer your question?
Yeah, that's a good one. I like that answer. You type it into my Slack channel too. That's actually pretty clear answer to that. It happens a lot. I think a lot of our community user does ask that. That's when they get the confusion. I do have another question. If you have, I think we still have time. Can you provide just a little more details on how Alluxio speed up the storage read, and then how Alluxio serves the read buffer from training clusters?
So for the read part, basically Alluxio, the really simple thought is that we actually have a command to load the data from our under storage into our training cluster, maybe close to training cluster, the Alluxio cluster cache. So we load it once and then provide those data for all our training jobs. So that's the one simple way. And the other way is that we can put those data loading job in the backend and just wait for it to run and then accelerate our future data access. But at the same time, our training job can directly read the remote data, which is not yet cached in Alluxio. So we read and then we catch it and then we provide to training job directly. So those are two approach, and actually two combined can give us the best performance.
Cool, awesome, thank you. I
Thank
think,
you.
yeah, that is all the questions I have. I do appreciate it. Let me share my screen. Yeah, apart from the Alluxio Day event, so thank you, Lou, for reminding me of Sean's talk earlier. That was another Alluxio Day series where he dived a little deep into the CSI part. And then apart from the Alluxio Day event series, like I mentioned, which is more for developer focused on this one, we do have another event series called Alluxio Product School, which is slightly less technical and more user friendly, I would say, if you're new. And if you find Lou's talk pretty interesting and you want to learn more about Alluxio for AI and machine learning, and then you would like to, I want to encourage you to go check out a recent Alluxio Product School talk given by our product manager, Jingwen, last month on deconstructing machine learning pipeline with virtual data lake. So where she would dissect the machine learning lifecycle into 5 stages and going over the concept, functionality, characteristics, and use cases to demystify machine learning operations. And in that talk, we will also showcase how Alluxio, of course, has a virtual data lake that helps to simplify each stage. I will later on post the video link of that talk as well as Sean's talk in the Slack channel, both in the troubleshooting one. So you guys, if you want to dive a little deeper or go a little higher layer, you can go over in any of those. Again, you can find our speakers in the community Slack channel along with other Alluxio contributors. Please don't hesitate to post your questions there. And we also do have the recap pages up for today's talk as soon as possible when we're ready. And then we will send the links on the Slack channel and via emails for those registered audiences so you can have access to all of the presentations.